Hey guys, welcome back to another DirectX engine tutorial. In the last video we created a sprite and we actually rendered it on the screen. So in this video we can create an animation basically, animated sprite. And but before we do, we want to go back to sprite h actually, and we want to pass a value, another parameter and initialize. So you want to pass bool. Oh, of course, I don't know how that happened. I'm gonna pass a bool. It's passed in. What can I name it? I guess it's writable. I just set it to false. And in sprite, of course, make sure you pass it in here too. Bool is writable. And we want to pass it in here. Okay, now that we did that, now we want to create our animation sprite or animated sprite, whatever you want to name it. And this one we're gonna be messing with the UVs, and so I hope you guys know a little bit about that. I mean, I will create a picture for you guys so you guys can see a little bit better. But let's see. I'm gonna name it animated sprite. Animated sprite. Make sure it inherits from sprite and virtual destructor. Finish. Alright, number pound diff and def. Animated sprite. Okay. How do I do this? Let me see, hold on. Virtual methods, so I'm gonna include. Do I? Yes, I do. There we go. So make sure you wanna add initialize, update, and render. We don't even need virtual because I don't think we ever can inherit from animated sprite. I don't think so. Anyways, make sure you call initialize, update, render. All you can do is just copy and paste this, copy and paste it here. Want to add some private members, variables, members, methods, whatever. Actually, no methods. We want to first parameter, variable. We want to pass in our ID 3D11. D11 device context. The reason why I keep it in here because we can be calling it multiple times. I don't want to be calling it from engine multiple times. You're gonna be going to engine, going to graphics, and then getting context multiple times. I don't want to do that. So might as well just keep a reference of it. We're gonna create a float m current frame, float m previous frame. And the reason why we need a previous frame is to check to see if if the previous frame is different from the current frame, and if it's not different, and if it's the same, that means we don't have to update the Vertex Buffer, because it's kind of expensive trying to write the Vertex Buffer multiple times. So if it's the same frame, then we don't want to update it. I'm gonna have float m max frames. Float animation speed. Animation speed. We're gonna have a float m current speed. We're gonna have float m frames per second. And we have bool is looping, if you want to make it loop or not. I actually haven't even tested this one out. Actually, I should have done that. Anyway, in the constructor, want to pass in a float size, float frames per second, float animation speed, I'm gonna set that to 1 because it should be 1 unless you want to make it faster than it should be. Bool is looping, and I'm gonna set that to true. Why am I missing? Am I missing something? Oh, it's taking a while to pick that. Okay, so that's it for animated sprite. Alright, I went ahead, like always, I went ahead and did the functions in the CPV file. So in the constructor, you want to go to the constructor, and in here, you want to set the M frames per second. This one's going to be a little bit weird, because we have to determine how many frames you have to display a second. Basically, we want to find out how many frames it's going to be updating within a second. So in order to figure that out, we have to convert the seconds to milliseconds. So what we do, we want to say open close parentheses, and in here we know that 1 second equals 1,000 milliseconds. So we want to say 1,000. Divide that by frames per second. Doing that, we will figure out how many milliseconds it will take to update a frame. So let's pretend we have 2 frames per second. That means 5,000 milliseconds will update 1 frame, and then 1,000, which is a second, will update another frame. So we find out how many frames we want to display in a millisecond, and then we want to convert it back to seconds. And we divide that by 1,000 again. And then we figure out, and that's how we figure out how many frames it's going to be displaying in a second. I hope you guys understand that. It's a little bit weird, you know. You want to pass the animation speed. Animation speed. M is looping equals S looping. And current speed equals 0. In here, in destructor, are we deleting anything? No, we are not. We are not deleting anything. So when you go to the initialize function, like always, you wanna call sprite initialize. You wanna pass in the device shader textual file name. And it's rewritable. I mean, we know it's gonna be rewritable, but it's gonna write it's rewritable. I mean, we didn't even need this in here, actually, to be honest. You want just delete it because we actually don't even need it because we for sure know that it's gonna be updating. So what we can do is just delete that, call that, and just pass in true. Just make sure. Because for sure we know that it's going to be updating the Vertex Buffer. We call that, you want to set the M device context equals, did I pass? I did not do that. In here, right after device, you also want to pass in an ID. You know what, I'm just copy this. I do is context, device context. Got to do that. Pass it in here too. Device context. After we do that, device context, pass it in there. You want to set the M current frame equals 0. M previous frame. You want to set that to -1 because you want to update it at least once. You want to update it at least once. So we want to set the M max frames equals the float of M texture get width divided by M texture get height. In this way, we will determine how many frames are in this sprite sheet, and we know that this sprite sheet can be horizontal, so that's why this would work. And if it's not horizontal, this class will not work. We'll have to create more code for it, which, like I said, it's a simple engine, and maybe in the future I'll update it. I don't know, we'll see. But as of right now, we don't need it. So we want to go to update. you want to check if max frames equals 1. Let's say some reason you want to create a sprite that has only 1 frame. Then you just want to return, because you shouldn't not update at all. You shouldn't update any frames. And say if current frame is less than max frames. I want to pass a float. Oh, we need a DT in here actually. Alright, so since we need a timer, I want to pass include. I hope you guys got this timer class. I created this a while back. It's one of my tutorials in OpenGL. I'll put a link in the description. I already created this class before. I'm not going to create another tutorial on it. So I had to pause the video and add the file because I forgot. There we go. You have a timer. You want to get DT. Once you have this class, get delta time. We're going to have current speed. Say plus equals animation speed times DT. And you want to check if current speed is greater or equal to, no, not equal, equal to m frames per second. And if it is, then I want to update the current frame. You want to set the current speed back to 0. Make sure you do that. You want to set that back to 0, and then check if we have reached the end, that we have like gone to the last frame of this. If current frame equals is greater or equal to max frames, and you say if if m is looping, you want to set the current frame equals 0. Otherwise, you want to set the current frame equals max frames. Then you want to go outside and you want to check if current frame equals previous frame. And if it equals, then you want to return. I probably can't scrape that in one line. Basically, you want to check. There's no reason to lock / update the buffer if it's still the same frame. Otherwise, this is where our handiwork is going to happen. We're going to call it D3D11 mapped sub-resource, mapped resource. I'm going to call Vertex Buffer Vertex type, and get the vertices equals Vertex Buffer get vertices. And in here is where we want to update all of our UVs. So let's open Paint. I'm gonna open Paint so I can show you guys what exactly I'm gonna be doing. Let's make it a huge one. You know what? Or I may delete that. Let's increase this a little bit more so I have more room. Okay. We have that. We got this. So, like it's always, I'm not perfect. I'm creating just lines, whatever. Oh, probably a little bit more that way. I know it's not perfect. Let's pretend we had 3 frames here. We have a little. I'm terrible. How? Okay, whatever. We have a guy here. We have another one here. I mean, I'm not an artist. What kind of amp am I in computer? And we have another one here. I don't know. But basically, this is our frames, right? There's 3 frames. There's one first frame, second, and third. We know for sure that this point here is gonna be 0, 0, You know, and we know that this point from here is going to be 0, 1. I mean, I can explain to you how to get the UVs to make this animation. If you guys know already, you could skip this. I don't know. Just keep skipping to when I finish. But anyway, we also know that this point here is 0 and 1. And we know that this point here is 1 and 1. And by canceling stuff out, or I don't know what you want to name it, we know that we know for sure. Wait, hold on. I messed up. Hold on. It's not 0, 1. It's 1, 0. I was like, what the hell? That doesn't make sense. It's 1, 0. We know for sure. We know that y in here. We don't know this just yet. We know the y will be 1. And the same thing. Not 0. Why do I keep messing that up? It's 0. And we know the y here is also 0. And the same thing down here. We know that the y is 1. And the y in here is 1 again. So in order to find UBs in here, we know how many frames there are. And since we know we want to divide 1 by 3, we know that every texture UV mapping, it goes from 0 to 1. So you want to take this number and divide that by 3, or by however many frames you have. Okay? And by doing that, we'll figure out how many frames, how many, let me get this a little bit bigger. You divide this by how many frames they are. Num frames. And by doing so, we'll figure out how many frames you're going to be moving. So here we have 3 frames, so 1 divided by 3 equals 0.3, 0.333, and it goes forever, right? So we know that's the number we have to increment by. So from 0 plus 0.33 is going to be 0.33. 0.33 plus 0.33 is 0.66. And 0.66 plus 0.33 equals 0.99. And like always, you know, we're estimating. So eventually we'll go to 1. And since we know here, we know that this also is 0.33, 0.33, and 0.33, and 0.33. I mean 0.66. Sorry, I didn't want to confuse you guys. Hopefully I didn't confuse you guys. I'm doing my best. I'm stuck at explaining stuff, but I hope you guys understand what I'm talking about. So that's how we get the first frame. The first UV, we're going to pass into the first, to this vertex. The first vertex UV in here is going to be, we want to pass in the current frame. It's trying to figure out how to explain this. It's 0.33, 0.33. For the first vertex, we know that this vertex is 0. No, this is 0. Actually, apologize. This is 0, because that's how we actually initialized it, if you remember. Our vertices go a little bit weird. 0, 1, 2, and 3. And in order to get this, we want to create this point here. So in order to get that point, we want to say vertices 0 dot uv dot x, and you want to set that to m current frame and divide that by m the max frames. And we divide it by max frames because there's, in this case, there's 3 frames. So that's how we did here, basically. Same thing we're doing here. We divide that by the current frame divided by how many num frames there are. So that's what we're doing here. the current frame divided by the number of max frames. Vertices 0, UV, Y. And we know that for sure it's going to be 1. If you remember, this is going to be 1. Now we're going to get this. We know for sure it's going to be the same thing as this one, except the Y is going to be 0. So it's going to be the same thing as this one, but just that the Y is 0. Make sure you update this is not 0. Now you want to get the next frame. You want to get this point. In order to get this point, we want to increment the current frame plus 1 and divide that by the number of frames, and that will give us our next UV. So you want to get the current. I'm gonna say cur plus 1 and divide that entire thing by num frames. I'm gonna say num nf for num frames because it's not gonna fit there. You want to divide that entire. I want to say current frame plus 1 divided by number of frames, and that will give us our x and this UV. I'm gonna say vertices to the UV dot x. And make sure parentheses m current frame plus 1 divided by m max frames. Vertices to UV Y. We know for sure that that equals 0. And our last UV is going to be the same thing as this one, but just that the Y is 1. So that's it for this. I mean, that's how we calculate UVs to make an animation, to make it animate. I hope you guys understand it. I suck at explaining things, so I hope you guys got something out of it. If you guys know this already, then great. Then great. Then we want to do is lock the vertex buffer so it can be written to. We want to say h results equals m device context. We want to call map. I want to call m vertex buffer. Get vertex buffer. I'm going to pass second parameter equals 0. Third parameter equals d3d11 map underscore right discard 0. And you're going to pass map resource to fill in the values. And it failed, of course. I'm going to say results. And if it fails, like always, make sure you return. Otherwise, you're going to call vertex buffer, vertex type, because basically the new vertex pointer equals vertex buffer, vertex type pointer, and you want to say map resource.pdata. The pdata basically that's where it grabs the previous vertices that it has, and we can update that with our new stuff that we create on top. We want to mem copy vertices pointer with the new vertices that we created. Vertices size of vertex buffer, vertex type, and we know that it's gonna be 4. And vertex buffer, get vertices size. No, we know for sure it's 4. I know I'm gonna hard code that, but since we know that it's gonna be 4, it's 4. If you guys want to put a getter function in the vertex buffer to get the vertices count, you can do that too. So it's up to you. Probably be more cleaner that way, to be honest. So I suggest you guys do that if you guys want to. Anyways, you want to say m device context unmap. You want to pass in for parameter. You want to pass in the vertex buffer. and the last parameter equals 0. And then you want to update the previous frame. M previous frame equals M current frame. And that's it for the update. It's a little bit big, but that's what animation does. And now we're gonna go to our render, and we wanna go on top. You wanna pass in number include. I'm gonna pass in our engine because we're gonna need it. In here, yeah. In here, you wanna pass some engine. Get engine. Get graphics. And say enable alpha blending equals true. You want to pass in sprite, render, device context, world matrix, view matrix, projection matrix. And then you want to pass in this again, and you want to set it to false. So that's it. So that way it doesn't go through other stuff. And that is it for our sprite stuff. So yeah, we want to go to our framework or to our engine so we can update it and see how it looks like. Engine. So instead of sprite, I want to pass in animated sprite. Pass animated sprite. Go to our engine header. CPP. Delete. Initialize. Here, you will know that we want to pass an animated sprite. We want to pass frames per second. I'm gonna put 24 frames per second, and the rest is fine. We don't need anything else after that. And we want to pass on initialize. Which in here, we want to pass in graphics. Get device context. That's it for that. Do we need anything down here? We don't need that since we're already doing inside of there. Let's see, anything else? Alright, it looks like that is all for this. Let's cross our fingers and check to see if it works. No, it does not work. What did I do wrong? What did I do wrong? Sprite is... Okay, let me see. Previous frame, -1. 0. Oh, I never called update. Forgot. Doing. I never call update. M sprite. Update. There we go. Yay! We have a Mario animating. Haha. Awesome. So there you go, guys. I hope you guys like that. Another thing we probably want to do instead. You want to go to our Vertex Buffer. I think it would be much cleaner if we do it that way. You want to say int get Vertex count. Feels weird. It is kind of like an engine. It's not my engine, but still. I'm gonna pass int Vertex Buffer. Get Vertex Buffer. Return. Not buffer. I'm gonna fix that. Hold on. Get Vertex count. I'll go animate sprites. Let's go 4. And Vertex Buffer. Get Vertex count. Alright, cool. So there you go, guys. I hope you guys liked this tutorial. I know it was a little bit confusing. Hopefully you guys understood this. I'm not good at explaining things like always, but I hope you guys understood that. But there you go. There you go. Trying to figure out if there's anything else that I miss. Anything else did I miss? Anything else did I miss? Nope, that looks fine. Calls delete fine. There's nothing to delete because Sprite does it for me. And like always, you know, I created a class. I created a tutorial this beforehand, back when I was doing the OpenGL engine. So you guys want to go through that? I want to put the link in the description. If you don't have it, I'll put it in the description so you guys can look at it. So yeah. Other than that, let's see. Let's go to our engine. Let's lay it out a little bit more. Let's see. It's 24 frames per second. Let's make it 60 frames per second. Yeah, that should be so much. It's going super fast. You can barely see how many frames it's updating. And showing 60 frames per second. Wow, that's a lot. I mean, you don't want to show that much. Mostly it's only 24 when it comes to game. I mean, not games, but you know what I mean. There you go. There you go, guys. I hope you guys enjoyed this video. We finally finished the rendering sprite. Alright. Alrighty. So, our next tutorial will be to create a camera class. It kind of already is including it here, but it's a simple one. We want to make it better than it is in here. So in the next tutorial, we will create a camera class, and we'll yeah. I don't know. I forgot what I was gonna say, but yeah. We still, you know, what we have left basically is creating a camera class, which is our next tutorial. And the next tutorial after that is doing a resource manager to keep track of all the shaders and all the textures that we can need. So that way we don't create multiple of the same textures, because there's no reason for it, or the shader mostly. So I mean, I could either do a resource manager in the next tutorial or camera. Either way, it doesn't really matter. We'll see. I'll probably do a camera because it's short, because most of it is already there. Then we still have to create an entity class, where the entity, you know, everybody knows what the entity is, so I'm not going to go into it what it is. And then we have to create an entity manager that will manage all those entities. Then we want to create a game component class. The same thing I did in OpenGL, similar, exact same thing. And then, of course, we can create a player class where we can have movement, like in here in my actual. Hold on, let me. I'm building it. There we go. In my class, I created a player class where, and then I'm moving the character, or Mario. I'm moving Mario. So in our player class, we can move Mario. And then we also have to create our input class, which is the last thing we have to do. So input class will be the last thing we can do. But we still have to do the camera, resource manager, entity manager, game component, player, and input. So I know the cameras could be really short, and game component is going to be really short, and player, and input. So majority of it is it's simple. The only one that's going to take a while is probably the entity manager and entity. I know back in my DirectX11 tutorial, I created an entity manager and entity already beforehand, but this one's going to be a lot different. Back then, I didn't know what I was doing. Not saying that was a bad manager. It's a different type of manager. In this one, I'm going to do a different one. So, yeah. And resource manager should not take that long, to be honest. So, but yeah, there you go. That's our timeline or future milestones that we can do. So anyways, I hope you guys like this tutorial, this animated sprite, and I hope you guys give us a thumbs up and tell other people about it so they can know, you know. So yeah, and if you haven't subscribe like always. You know, we'll do my best to keep doing tutorials or stuff like that, or create let's plays, because I still like doing let's plays. Yeah, I'll see you guys next time, and we'll continue doing either the camera or the resource manager. So yeah, I'll see you guys then. Signing out.